this is Ms. DB. In this video we are going to learn about direct variation. So direct variation is a very specific type of a linear function, and a direct variation will have a constant of variation. So in a direct variation relationship, y varies directly as x, and k is called the constant of variation. So for example, the equation y equals 3/4 x is direct variation because it's in the form y equals kx, and in this case k would be 3/4. So all direct variation problems are like this, equations are like this. They all have y equals something times x. There's nothing added or subtracted from the end. So another way of thinking about that is that the y-intercept is always 0. So if you think about a equation of a line in slope-intercept form, it would be y equals mx plus b. Whoops, I got two y's there. And in direct variation, we don't have the b. Now, they call this number the constant of variation, but it's really the same as the slope because it's in that same exact spot. So for example, here's a graph of a direct variation problem. This is of a snail traveling 2.6 feet per minute. So we write a direct variation equation and graph it. That's what you'll be doing on several problems. So the constant of variation in this case is 2.6. The equation would be y equals 2.6, and to graph it you would just, you know there's a point at 0, 0 because all direct variations have one, and then you would go, the rise is, I guess, 2.6 and the run is 1, so this one's a little tough to graph by hand. You can also make a table of values, and you can let, it'll of course be 0, 0, but then you can let x be 1 and see what y is, and let x be 2 and see what y is, and so on. Or you can use technology to graph these as well. Up here we'll talk about this in a minute. That's the other thing we'll do is if we're given that y varies directly with x, what that means is that you have a direct variation equation, and then they give you some more values. You can use that to find k, and then you can write an equation from there, and then you can find other values and so on. Alright, so the first part of this worksheet you're going to be writing and graphing. So you're going to write an equation and you're going to graph the function. So for example, let's look at the example problem first. It says y equals k times x. That's the standard form of a direct variation equation. So you're always going to write that when you are going to start doing these problems, that y is equal to kx. Then we need to find k. So we'll take what they give us. The y is 14, so that goes here, and the x is 3.5, so that goes over here, and then you solve this equation to find k. Once you find k, then you can write your direct variation equation. And once you have your equation, you can graph it. You can graph it by plotting points, or you can use your methods using technology, or you can know that the slope is 4, or 4 over 1, and you can graph it from that. Alright, so let's look at number 1. We are given that this is a direct variation equation, so again you can start off by writing y equals k times x, and then we're also given that y is equal to 18. I'll move this up a little bit. Y is equal to 18. We don't know what k is yet, but we are also given that x is 6. And that's enough information to solve for k. We'd solve for k by dividing both sides by 6. And then that gives us 3. 18 divided by 6 is 3. So now we know what k is. So this is what you would do for part A of this problem. Then for B, it says write the direct variation equation. Well, all you need to do to write the direct variation equation is replace k, y equals kx, but replace k with what we just found that it is equal to. That's the direct variation equation. And then for C, you have to graph it. So this is pretty easy to graph. We know that it's going to go through at 0, 0, and then the slope is a rise of 3 and a run of 1, so I need a point about right there. So let's see if I can get my pens to work here. I know there's going to be a point at 0, 0, and another point at 3, 1. Maybe I'll put another point at 6, 2. And then I need a line through that, and I don't want to just draw from here to here. I want the line to go all the way to the edges of the graph. So I'm using my word tools like I've shown you guys before to insert a shape, and I'm going to choose the line, and then I'm just going to, whoops, it didn't work. I moved the graph. Trying to get it back to where it was. Try that again. I'm going to make my line over here and then I'll move it so I don't do that again. Make it a little darker, a little fatter, so you can see it better. Okay, so now it's probably not the right slope, but I'll adjust it once I get it over here. I know it has to go through 0, 0. Swing this up a bit. So you kind of get the idea. I'm a little bit off, but it's close enough. So once you get your line, then you're done with this problem. And again, you could graph this in Desmos. You could just type y equals 3x, and then you could get a screenshot of your graph and paste it here. You could take this one away if you want, or you can paste the link to the graph too. Or you can use GeoGebra or Sketchpad. There's lots of options. So you're going to do the same thing for 2, 3, 4, and then we're going to solve some direct variation problems. So in order to solve a direct variation problem, you're going to take the given x and y values and find k. Same thing as we did before. Then again, step 2 is to write the equation, same thing as we did, and then you'll use that equation, so we don't need a graph, but we're going to use that equation to solve for the other one. So they'll always give us 3 numbers here, and you have to be careful that you're using the right ones in the right time. So if y varies directly as x and y equals 52 when x equals 4, that's all you need to do the first 2 steps, right up to here. I was trying to highlight that, but it wouldn't highlight because it's an image. So I'll underline it instead, right up to here. Don't use that x equals 6 at the end yet. So step 1, same as before, we need to find k. Step 2, write the equation using k, replacing y and x where they belong. And then step 3 is when you would finally use this piece of information. So step 1 is for here, and from step 2 you get from step 1. All right, let's try, number 5 has a lot of the steps started for you, so let's look at one that's not started as much. Let's look at 6. So the dollar amount D that Julia earns varies directly as the number of hours T that she works. So it's not X and Y, but that's okay. We can still write a direct variation equation and we'll still use K. Okay, so D equals K times T. And let's make sure that's right. The dollar amount D that Julia earns varies directly as the number of hours that she works. Right. Okay, now we're going to use these 2 things to find K. So D, we'll replace D with 116.25, and that's equal to K times 15. And then we solve this to find K. All right. 116.25, and divide that by 15. And this will, oops, it looks like I had some other stuff saved on my calculator. Try that again. So 7.75 is K. All right, so we have, that's A. We've done that, that's part A. For B, we need to write the equation. All we do is we take what we got for K and we replace it right here. So D is equal to 7.75 T. And then C, our last step, is to solve using that last piece of information they gave us, which is find T when D equals 178.25. So I'm going to replace D with 178.25, and the rest of the equation will stay the same. And I need to solve this for t. So I just need to divide both sides by 7.75. So get our calculator back out. 178.25, and divide that by 7.75. And we get 23. 23 equals t. And this was, t was in hours, so I would write 23 hours for this. And that's how you'll solve these problems. And there's a few more that you'll do the same thing. Number 11 is a little bit different, but I think I'm going to let you guys see if you can figure it out. This one's asking if it costs $100 to rent a recreation hall for 3 hours and $150 to rent it for 5 hours, you might want to find the cost per hour. And if it's direct variation, that will be the same for both of them. So if it's not the same for both of them, then it's not direct variation. And then there's a few other questions about assuming it is direct variation, what could you do? Alright, so let me know if you have any questions, or if you get stuck, you can come to my office hours or to the ASC room or send me an email. Thanks a lot and have a great day.